Right. So my name's Patrick Smith. I'm a chief learner at IOTA School. We do accessible infrastructure development and teaching and curriculum development and accessibility work. I'm also a blind technologist and teacher and researcher. So it's kind of my utmost pleasure to introduce Josh Miele, or Dr. Josh Miele, who is someone who has done things that I truly admire. So Josh, I'll kind of start from the beginning. Josh got his undergrad at in physics at UC Berkeley, and I didn't know about this when we invited you out, Josh, but I read that you had an internship at NASA, which is pretty cool. So that's a connection here. But then he went on to get his PhD in psychoacoustics, also at UC Berkeley. And then Josh spent many years at Smith Kettlewell Eye Institute from 2007 to 2019, where he was Associate Director of Research and Development. And there he worked on some truly amazing projects. So they include TMAP, so tactile, I looked at this 20 times, and tactile maps automated production, which essentially allows you to emboss or print out a Braille map from a home Braille embosser. He also, which sounded like an incredible undertaking, helped create a tactile maps for the entire BART system, including platform maps and street level maps, which sounds like an incredible undertaking. He's created systems for typing using haptic feedback. And he's also created projects like UDescribe, which is a crowdsourced system for creating and hosting audio descriptions for YouTube videos. And one of my personal favorites is the Blind Arduino project, which is this incredible maker learning website that I've used a couple of times. Arduinos are like little microcomputers that you can use for all sorts of maker projects and wearables and all that kind of stuff. And there's some really cool geeky stuff on that website, which I really enjoy. So Josh, now, since 2019, he's moved on to Amazon Lab 126, or 126, and where he is the principal accessibility researcher. And he's worked on things such as Braille accessibility in the Fire tablet. And Josh has some really cool big ideas that I've enjoyed listening to him over the years talk about, and one of them being, which I hope he'll talk about a little more about, but combining different modalities, accessible modalities, so combining audio with haptics. But another one which I've really enjoyed is this idea of metamaking, which is really the idea of kind of like bootstrapping your way into, like, if tools for creating other things aren't accessible, like you create tools to create tools, and you kind of bootstrap your way into making amazing projects and technologies. So, and of course, in 2021, Josh he received a MacArthur Fellowship, recognizing all his contributions in accessibility and technology. So I'd like to welcome Josh to Space Telescope Science Institute, so I hope you can give him a round of applause.
Wow, thanks so much, but I think you pretty much covered it, so we could just go to lunch. I'm super pleased to be here. Thank you for that great introduction, and thank you for the invitation to speak to you here at the Day of Accessibility for the Space Telescope Science Institute, which I'm a nerd. I am just thrilled to be here. It's really exciting. So what we're going to do, I'm giving you the most accessible PowerPoint presentation in existence. There are no slides. Thank you. Yep, applaud. Go ahead. That's fine. As a blind student, a blind scientist, a blind everything, PowerPoint. It's just not that great. So So not only do I hate preparing slides, but it always makes me sad when people are giving these great presentations and they're sort of talking more about the slides than they are about the thing that they're really talking about. So no slides, and if you want folks online, it's perfectly acceptable. You can walk away from the screen, treat it like a podcast. There's nothing to see here. I just I'm going to give you a quick overview of what I'm going to try to cover today. I'll give you a little background on who I am and where I came from, and sort of why I wound up in accessibility, and talk about some of the projects that were mentioned, and kind of try to give you a sense of why I do the things I do, and to help you think about ways that you can improve accessibility as well for yourself and for everyone else. I know there are many people here today who are students with disabilities. There are teachers and parents and disability and education professionals. I know there are a bunch of folks from there should be a nice way to pronounce STSI. How do you guys pronounce that? STScI? Anyway, but I know there are a bunch of folks, engineers, scientists, and staff from the Institute. So I'm going to try to offer something of interest to everyone. I'm going to kind of come at this from the angle of telling you sort of, I mentioned that I'm a blind scientist, I'm a blind researcher, activist, and I put blind first. I am not a person who happens to be blind. I am blind in everything that I do, and I'm proud of it. And I'm not trying to minimize it or make people sort of not pay attention to it. I didn't always have that attitude. When I was young, I really didn't want people to pay attention to it. I did want to minimize it. And in some ways that served me well, but in other ways it didn't. And so I just want to sort of tell you that in my ultimate journey as a person with a disability, as a blind person, my thinking is that the more you are upfront and direct about your disability and what you need in order to interact and succeed in the world, the better off you will be, and the better off everyone else will be. The better off the people around you will be, because there'll be clarity about what you need and how you need it, and the better off will be the people who come after you, who you are. We are always clearing the path for the next generation. Even if you're really young, there will be people coming behind you who are the next generation, and who you will be sort of treading that path for before they get there, and making it, stamping down the snow, making it better, easier, and more possible for them to succeed in doing the things that they want to do, which is ultimately what accessibility is about. So let's talk about briefly, how I think about accessibility, and it's really. I go back to, I'm a physicist. I like to go back to first principles, and I think about accessibility not as an exhaustive checklist on the W3C website, not as a set of things in the 508 laws, but as a set of design requirements. And the design requirements are based on who you're working with and what the situation is. So really, there's no. You have to go back to the beginning in order to understand what accessibility means in any particular situation. So whenever someone says we need to make this accessible, the first question you should ask is, accessible for who? And the way we've been thinking about universal design over the last couple of decades or so is basically we try to make something as, we try to think of as many situations as we can. We try to build in as much stuff as we can to make as many people be able to use that thing as possible. We're thinking of it a little differently now, and that is more in terms of customizability, the ability for anybody to be able to turn on or off, activate or deactivate, or engage with or not engage with different parts of the experience to adapt it to what they need. And ultimately, what we're trying to do with accessibility is make the experience, whether it's an architect, a building or a city or a class or a website or a computer, any of these things, we're trying to make it so that a person with a disability can use it in pretty much the same way as somebody else would use it. Oh, sorry, not the same way. Let me rephrase that. With pretty much the same experience that someone else can use it. There may be different, you may use it differently. You may need to use more keyboard commands rather than a mouse. You may need to read the Braille on the room numbers rather than looking at the print. There are different ways of accessing information, but ultimately, you want the person to be able to access that, that experience. You want to make it an equivalent experience, right? So a story I often tell is, think about going up to a beautiful building and there's this grand architecture. The San Francisco City Hall is a great example. It's like this beautiful Art Deco building with a dome on top and lots of stained glass and huge sweeping steps up to the front doors. And you roll up to that in a wheelchair, and you can't walk up those steps and into the grand atrium. You roll around back, you go into a side entrance, you go through the basement, you find the service elevator, you go up the service elevator, you roll out of a dusty hallway and into the atrium. You got there, but you didn't have the same experience of getting there that a person who just walks up the steps does. So I don't think that's accessible. You got there, you were able to achieve it, but you didn't have the same experience. You did not have that grand entrance. And accessibility we need to think about the experience, not just the compliance, not just does it work, but is it delightful? Is it giving you the same experience as was intended by the original design? And that's why, I could talk about this for a super long time, but I think the point being that if it takes you 10 times longer with a screen reader to do something than it takes somebody else without a screen reader, yeah, okay, you can do it maybe, but that's not accessible. That is not, you're not getting the same thing out of that. And so growing up as a blind kid, going through school, I felt like a lot of the time, it seemed like I was inventing stuff for the first time. I had to, there were things that, I had to work with my teachers and with my TVI, my Braille teacher, to come up with systems for how am I going to do geometry? How am I going to do chemistry? How am I going to do, and sure, there were tools like Braille and other things, but I want to emphasize how important tactile graphics were to me in learning to do in STEM, in my STEM education, right? I studied, I took a lot of math in high school because I don't know, I liked it. And I took a lot of science, and without the assistance of the teachers and the other students, my lab partners and so on, I wouldn't have been able to do it. I wouldn't have been able to get access to the tactile graphics or the materials. There weren't any accessible balances, for measuring out chemicals. I had to work with a lab partner. They had to tell me what was going on. So this opens up a question of what is independence, right? Independence is often thought of as being able to do something yourself. But I think, in accessibility, a lot of the time we need to think a little bit more broadly about independence. Independence is really control over how things unfold. A lot of the time you may not have an accessible instrument that you need to, in order to do your science lab. You may not have accessible graphics. Not everybody gets the privilege of having tactile graphics for everything they need. So you need someone to describe it. But the more control you, as the consumer of that, the student, have over that process, the better. And I would sort of offer sort of control or sort of agency as another dimension of sort of accessibility and independence. So growing up, these having access to tactile graphics was really important, and it fed my love of maps and of access to information. By the way, that's how I think of myself, is as a researcher who studies the accessibility of information. That's largely what blind people need, is better access to information. Different folks with different disabilities need different types of access. For if you're using a chair, one of the things that you need is architectural access. So for me, growing up, and as as a student and later as a scientist, I was constantly trying to figure out, how am I going to get access to the information I need in order to do the things I want to do? And so that has really motivated a lot of the work that I've done. Example, when I was in graduate school, everybody was using MATLAB. I mean, how many of you have heard of MATLAB? Just say me. All right, cool. MATLAB, so I lived, thank God notebooks weren't invented yet, because otherwise I might not have graduated. But in my lab, everybody was using MATLAB. So MATLAB is basically, it's like Excel on steroids. It's a data management, manipulation, and visualization engine, which has its own little programming language that's very much like C, and has a bunch of rendering tools for displaying data. And so it was really cool because the command line, it was all driven by a command line. It was really easy to use, but the data visualization stuff was completely inaccessible. So all of my colleagues were using MATLAB to, not only to create their stimuli and manage their data sets, but also to, create pretty graphics for their presentations. And also not just for their presentations, but in order to analyze data, right? Data visualizations are super useful in for figuring out what your data means. That's what they're for. So I didn't have access to any of that. So I spent the first year of grad school writing a MATLAB toolbox for sonification and tactile output. So I wrote basically a set of tools that would turn my data into sounds that I could understand and interpret. And then for the data that I wanted to really dig into, I wanted to print it out and feel it. I wanted a tactile representation. I wanted XY axes, and I wanted to see my scatter plot and my error bars and all of the things that I would need in order to interpret and understand my data. So I wrote this toolbox, and it was, this is an example of what we were talking about when, sorry, I'm blanking on the guy who introduced me, his name. Tell me your name again. Patrick. I was like, Patrick, okay. Patrick mentioned this whole MetaMaker thing, right? Where I'm basically convinced that people with disabilities are put in these situations where they can't do the thing that they want to do, like go to grad school and use the same tools as everybody else. And so what happens is you have to create the tools you need in order to do, before you can actually do the real thing that you wanted to do. So in writing these tools, I became a total MATLAB badass. And you know, it served me really well for the next 4 years. When I got out of grad school and got a postdoc at Smith Kettlewell. So Smith Kettlewell is a cool place where basically one of the groups that they have really focuses on research and development of accessible tools for blind people around STEM. A lot of it is around STEM. So the first thing I did was, you know, as I mentioned, I've always loved maps, and I've always been. This was a long. I'm hell of old, you guys. This was in 2001. Okay, when I started my postdoc, and there were no Google Maps yet. Maps were a thing that you either had on paper, or if you were like a real nerd, you had access to GIS and some digital maps. There was a thing called, believe it or not, Yahoo was the big map provider at the time. And so I was like, I want maps for blind people, because they were starting to be, these street maps were starting to be readily available online for everybody. And I thought, I want that. I want to be able to look at street maps, because when I go to a new place, the only choice I have is either getting detailed descriptions of the street network and sort of trying to remember it, or just go there and get lost. And that's usually what I would do. You know, I would just leave 3 hours early so that I could like find my way to the place that I was actually trying to get to, which is, you know, not, again, you know, is that, you know, if I have to leave 3 hours early, that's not really equitable or accessible. So I proposed as my first postdoc project this project where I would create tactile. I would use an algorithmic approach to producing tactile street maps of any place in the country. And in order to do that, I had to learn all about GIS. I had to learn all about how to render tactile, tactile maps. I had to do a bunch of research on what kind of information people wanted and could use on tactile maps, because, you know, obviously I'm blind, but I am not every blind person. And so all of the work that I have done, you know, over the course of my career, you must do customer research, user research. You can't assume anything about what your own preferences are not what everybody might want. And there are, you know, for as many different kinds of blind people as there are that many different kinds of use cases and needs. And so it's always really important to work with the community of people who are going to be using the tools that you're developing in order to make sure that they're usable. Now, of course, as a blind person, I don't have to start from square one. I can sort of start from square 5, right? Because I can eliminate the things that I know are bad ideas, and sort of start working with the things that the options that I know are sort of within reason, and then get feedback. So I did that with the maps, and these maps, the TMAP for the first time allowed blind people to have access to pretty much any street map they want anywhere in the world for free or at low cost now. So I, for a number of years, sort of ran it as a research project, and then I spun it off to the San Francisco Lighthouse, who now owns it and maintains it. And you can get in touch with them at lighthouse-sf.org to get any street map you want. It's not, they also have a website that you can go to, and you can download and print out your own street maps, or you can have them do it for you for a fee. So this project sort of lives on and is a great example of kind of, oh, by the way, I didn't tell you, I built it all in MATLAB because that was all I knew how to do. And so it was just built with, kind of chewing gum and other stuff. And and when the Lighthouse took it over, they rebuilt it as a mature web-based app that uses appropriate APIs and all of that. So it's a real thing. That's an example of the kind of tool that I think is really amazing. So, Patrick mentioned UDescribe, which is another approach that I worked on for access to video. I've done a lot of work in video description technologies and thinking about how we can get better access to audio description of videos for education, for entertainment, for training and employment, all of these things. Video accessibility is hugely important as text accessibility, I would say. But I can't probably talk about all of the various projects I've done, but I'm going to jump to talking about the Blind Arduino project because I think it illustrates a bunch of the things that I think are really important. Let's see. I'll also tell you, Patrick mentioned that I'm at Amazon now, and I'm not going to talk a lot about what I do at Amazon. That's, there's plenty you can read online about that. I love doing what I do there, but in my transition to Amazon, I thought about I had been working at this research institute for years and years. I wanted to sort of scale up my impact on the world. I wanted to do accessibility, not just research and development projects that I would publish about and show demos of, but I wanted to do things that would really reach people and help people do the things they wanted to do. And so I started thinking about how can I get a job in tech? And I found a recruiter online who I put together a resume of all of the work that I had done and sent this recruiter my resume. And I basically said that I was a designer, because essentially in all of this, what I do, I often work with engineers and other folks. I am not writing the code necessarily for, I didn't write the code for UDescribe. I didn't, once you get to these projects of a certain level of complexity, you can't do it by yourself. Again, it's independence. What is that? You need other people to help you do things. So I had designed UDescribe. I had designed TMAP. Actually, I made TMAP myself. But there were a bunch of other projects where I was the designer and the sort of project lead. And so I sent my resume to this design recruiter. And she called me back, and she said, and I had told her I was blind, and she said, I think it's so interesting that you think you could be a blind designer. And I said, I think it's so interesting that you think you're going to help me get a job. So obviously she was not going to be very helpful. And I say this to illustrate that technology is really cool. Technology is helpful. Accessibility is the technical end of disability inclusion. And what we're really, the technical parts aren't actually that hard. They're sometimes very difficult, but they're just implementation details. The hard part is the social engineering, the social dynamics of ableism and figuring out how to change attitudes in the world, not just among people without disabilities, but there's plenty of internalized ableism among our own people to prevent us from achieving what we're capable of. So the Blind Arduino project. sort of gets at all of it. It gets at the technical stuff, it gets at the social stuff, and that's my favorite kind of project. And what I do in the Blind Arduino project really is to work with other people to teach and develop training materials for showing blind people how to work with this microprocessor platform. How many of you know what Arduino is? Just say me. How many of you don't know what Arduino is? Oh boy, okay, it's a lot of people. So, so Arduino is a little computer on a circuit board that lets you, that is, it's open source, it's cheap, and it's available everywhere, and it's sort of the heart of the hobby robotics movement. So when you are, when you're working in your hobby robotics club or whatever, there's a good chance that the things that you're building with are Arduino computers. And Arduinos are cool because you can write a program, you can load them onto the Arduino from your computer, and then you can attach that Arduino board to all kinds of switches, buttons, sensors, motors, lights, buzzers, switches, oxygen sensors, you name it. Whether it's a sensor or an actuator, you can connect it up to Arduino, and you can tell your program, when I push this button, do this. Or when you detect a certain temperature, do that. Or when the lights go off, do this other thing. And the doing can be anything from connecting motors and driving some physical process to sending out a tweet or doing some cloud-based thing. So Arduino is super cool and flexible, and you can build the kind of stuff with it in an afternoon that when I was a kid, you would have had to have a team of IBM engineers and $1 million to build. But so I mean, it's really flexible and powerful. And so what I am interested in doing is, number one, teaching blind people how to build their own accessible equipment with these Arduinos. So, well, actually, number one, showing blind people that they can work with these things, that you don't need to know what color the wires are. There are alternate methods. There are, you don't need to be able to see and read the numbers on the circuit board. All you need is alternate documentation that's in an accessible form. So all of these things, there are workarounds, there are ways of doing these things. And part of what I want to do is show blind kids that and adults that they can do this. And part of what I want to do is show sighted teachers and club managers that they can do this. And when I've run workshops, where I teach soldering, or I teach Arduino basics, and I'll say, how many of you guys in your school have a robotics club? And these are all, blind kids, 10 to 15 or 16, whatever. And everybody will say, they're usually mainstreamed. Everybody will say, oh, me, my school has a robotics club. They went to the first, robotics thing last year or whatever. And I say, how many of you are in the robotics clubs at your school? And there's silence, because these STEM learning opportunities that are just so ubiquitous for kids who can see, kids without disabilities, the teachers are not understanding how to include blind kids, how to include kids with disabilities into the robotics clubs. So that means that these kids aren't going to have the same level of experience coming out of junior high or high school, going into college. They're not going to have the same level of background, the same experience as the sighted kids. They're not going to be as capable as sighted kids to go into STEM fields. So this whole, it's got a snowball effect that when people are excluded from learning experiences, it affects their entire future, and not just the future of the individual, but the future of our society. Because when blind kids do learn these things, and by the way, it's not just the blind kids that learn these things, but sighted kids come and learn alongside them, sighted grown-ups come and learn. And again, it's collaboration. It's not, I'm not trying to build a blind-only world. This world includes all of us. And kind of accessibility is everybody's responsibility. It's the responsibility of people with disabilities to say what we need and to make sure that it gets built right in ways that meet our needs. It's the responsibility of teachers to make sure that they know how to teach kids with disabilities, so that in the future, when these kids are in the tech world, getting tech jobs, doing tech things, that accessibility is no longer, I think that we're coming to a place where accessibility will not be this thing that people think about after they release an inaccessible product, but things will be moving in a direction where technologies are born accessible because we have people with disabilities at every level in the tech world, in the world where these things are coming from. We only produce inaccessible tools when the people producing them don't realize that there's a need. If we had people with disabilities working in tech, in software, in hardware, everywhere, there would not be that excuse. Oh, I didn't even think blind people would need that. They do. We do. And so the Blind Arduino project is really this kind of long-term social engineering project, not only to teach about accessible design, to teach people to build their own tools when they need them so that they can do the things they actually want to do, but it's for the teachers, it's for the parents, it's for the future people who will be developing the accessibility affordances of the future, so that, as I said, we don't need to, the people who come behind me don't need to call up a recruiter and have a recruiter say, oh, how interesting. And so that the kids who are going to school don't need to say, I'm not in the robotics club because I'm blind. That's not the world where I want to live, and I don't think that's the world where you want to live. So I guess my takeaway is that disability and accessibility are, accessibility is a key component of disability inclusion, but it is only the technical part of it. And our real challenge, our real responsibility in true sort of broad spectrum disability inclusion and accessibility from a sort of societal standpoint is that we need to figure out how to shift our social expectations so that we're not surprised when there are people with disabilities working in every job. And maybe that's a little grandiose, but that's where I want to go, and that's where I want to encourage you to be, thinking about as the end game for disability inclusion. And I love that the Unpronounceable Space Telescope Science Institute has this as part of their mission. And this is why we do the alt text. This is why we do the Jupyter notebooks. Without accessible Jupyter notebooks, we will not be producing future scientists who need the accessibility features of notebooks. Without good alt text, we will not be inspiring people to become astronomers and scientists. So I'm gonna just say again, thank you for inviting me. Thank you for hosting this event, and I'd love to take questions if there are any.
Thank you so much. That was wonderful. Okay, we have 12 minutes for questions. Any hands in the audience? Oh, I see someone right here.
And remember, please, to say your name.
Oh, can you say your name?
Oh, my name is Paul, and what was your favorite product that you made? Was there a product that helped you?
What was the favorite project that you made?
Thanks for the question. You know, I love all my babies equally. But I got to say, YouDescribe is, I'm super proud of YouDescribe because it's a, not only does YouDescribe, basically it's a website that lets anybody, anywhere, go to watch a YouTube video and add audio description to it. You can do inline or extended audio description. You can record it with your voice and it plays back when anybody else, anywhere else in the world can then watch that video with your audio description. Any number of people can add their own audio description, so you can have like multiple audio description tracks. And there's no, and it doesn't violate the YouTube terms of service. And it's basically like, I love technologies that invite us to think differently about what accessibility really means. And when you've got an audio, if you turn on audio description, you basically have one option for audio description, and it's some some sort of authoritative, voice of God that tells you like what the description is. And it's like, sometimes that's, especially for social, like that's kind of okay for big blockbusters maybe, but for social media, for other videos, there are other voices, there are other ways to describe. Like if I post a video on YouTube for my buddies, of a ridiculous birthday situation where like the cake falls in the mud or whatever, I don't want I want to describe that in a certain way for my friends, and somebody else may want to describe it in a totally different way. Audio description is not one size fits all, and I think that it's really cool to I love that there's a tool that invites other voices like teenagers and elders and folks who are sort of huge subject matter expertise. If I'm a scientist watching a video about a science demo, I'm going to describe that differently from the way a kindergarten teacher would describe it, right? So I think that YouDescribe really invites us to think creatively and differently about what audio description, what description is in general. I think description, by the way, is, I think we should think of description as an accessibility tool, sort of almost like no other. If you think about it, all a screen reader is a tool for description, really.
Okay, any other questions? Oh, I see a hand. Oh, wait, here, let's start with Eric's.
Hello, my name is Jamin. My question is, what project are you most involved in? And nice to meet you.
Nice to meet you. My day job at Amazon keeps me super busy. And I do a lot of stuff at Amazon that I love doing. It is extremely fulfilling, fun work. What I do there is help make the Amazon devices, such as the Fire TVs and Fire tablets, more accessible for customers with disabilities. That is one of my favorite projects, that I'm working on at work. Personally, I've got a lot of smaller projects that I work on. I am in the Blind Arduino project is something that I'm still heavily working on. I also am starting a nonprofit that is called the Center for Accessibility and Open Source. It is intended to support the accessibility of open source and open source accessibility. And I'm super excited to talk to the Notebooks people about that a little bit more.
We're excited to talk to you too.
You're bugging out over here.
So yeah, so those are the kinds of things that I'm actively engaged in right now. Other questions? Like, where's lunch?
A couple more minutes before lunch.
Thank you. Hi, my name is Kelsey Brown. I'm at the Air and Space Museum in DC. And I was just wondering if you have, I know this is like a whole conversation, but if you have any kind of quick suggestions or recommendations for things that institutions like museums can do to support your work and to support accessibility? I know it's a whole thing, but if there's one thing that we could just do better in your experience.
Well, the first and most important thing is to engage people with disabilities, not just patrons, not just advisory boards, but employees and experts. There's a big difference between, somebody who just lives with a disability and deals with stuff for themselves, and somebody who is has a disability, has the lived experience, and is also an expert in that, in sort of providing accessibility. So the zero order solution is to make sure that there are people with disabilities who are accessibility experts working in the museums in the accessibility areas. And then the second most important thing I would say is make sure that the people at the front desk are well informed about what accessibility offerings you have.
Hi, my name is Paulo. So, I was just wondering if they create, if you can create technology that, kind of like a sunglasses, but except like, where it tell you when to cross the street, or like have a voice system where it had camera to detect traffic versus the traffic light. How would it tell whether it's safe to cross or not?
So I'm gonna either ask you to repeat it or ask somebody to help me understand what you.
I think, he could repeat it, but I think I heard what he asked.
You want to?
Oh, do you want to? Yeah, go.
Yeah. Paul, was it that you would like someone to maybe start working on an invention that would allow people with a visual impairment to know when it's like safe to cross the street that's a wearable?
Oh. Yeah, that's a really interesting problem, and that's I think that there are, people love that problem. I have a little Google alert that that tells me whenever there's somebody publishing about disability technology, travel, wayfinding, stuff like that, and there are so many little projects that people create that sort of try to help blind people navigate in the world, try to help blind people cross the street, try to help blind people do this or that. And I think it's so interesting because so many of them don't really start from what people really need. So often, the people that are, they're people, they're well-intentioned, but they don't have disabilities. They aren't blind. They don't have any blind people working with them. They just sort of watched, some movie about blind people, and they think they know what blind people need, right? So, the sort of substituting myth and prejudice for market research, and so I think that there are lots of tools that would first of all, nothing's ever gonna tell you that it's safe to cross the street, right? The liability is out of control. So there are legal reasons why people aren't making devices that sort of help people make decisions about when it's safe to cross the street. I think that there are some really interesting tools that we could use. For example, there's a thing called visual looming, which basically you can use a camera to tell when something is approaching you or moving away from you. And it doesn't, it doesn't have to do any fancy object detection. It doesn't have to do any fancy sort of identification of what things are. But at a very simple image processing level, you can really easily and quickly tell whether something is coming towards you and how fast it's coming towards you. And that's really something that would be very useful for folks to know. And the other requirement on a thing like that is to give you information in a way that doesn't interfere with the rest of the, you need to listen, you need to pay attention to what your auditory cues are. And it also needs to be, there needs to be like no latency. Like, I don't want to know 5 seconds later whether there's a bike coming. I want to know like right now. So, and I think that another really, this is another great example of where open source accessibility tools may wind up providing these kinds of gadgets for us, because if it's just an open source tool, there's nobody to sue really, right? And whereas the lawyers would sort of, if you left it in the hands of the lawyers, we would never get tools like that, because it's just there's too much risk to the person that provides the device.
Okay, well, with that, I think we've made it to lunchtime. Let's give another round of applause.